Revolutionizing research, the rise of autonomous AI scientists promises a 1000x acceleration in scientific discovery. Date, August 4, 2025. Executive Summary. The emergence of autonomous AI scientists is set to transform the landscape of scientific research, potentially accelerating discovery rates by a staggering factor of 1000. This technological revolution is driven by significant advancements in artificial intelligence, particularly through innovative platforms developed by pioneering organizations such as FutureHouse and Sakana AI. These entities are redefining the research paradigm by automating key scientific processes, thereby addressing the stagnation in productivity that has plagued the research community. 1. Integration of information from all sources. FutureHouse, revolutionizing research collaboration. Founded by Sam Rodriguez and Andrew White, FutureHouse aims to tackle declining scientific productivity by employing AI agents to automate various research tasks. Their platform integrates tools for information retrieval, synthesis, experimental design, and data analysis, enabling researchers to optimize their workflows. The launch of AI agents, including Crow and Owl, has demonstrated remarkable effectiveness. For instance, they have enabled researchers to discover novel treatment options for diseases like polycystic ovary syndrome and Alzheimer's disease by quickly processing extensive literature. Sakana AI, the AI scientist. Sakana AI has introduced the AI scientist, a fully autonomous research system capable of generating hypotheses, conducting experiments, and producing scientific manuscripts, including an automated peer review process. This AI has already contributed to machine learning literature, producing papers on topics such as diffusion models and language modeling, and signifies a leap toward independent research capabilities. 2. Common key points. Both FutureHouse and Sakana AI underscore the necessity of automating complex scientific tasks to combat the decline in research efficiency. They leverage large language models (LLMs) to interpret and generate scientific content, demonstrating a shared belief in AI's transformative potential for knowledge creation. Furthermore, both organizations aim to democratize access to advanced scientific tools, making them accessible across a variety of disciplines. 3. Distinctions between approaches. While FutureHouse emphasizes a collaborative framework where AI agents assist human researchers, Sakana AI envisions a fully autonomous entity that can manage the entire research lifecycle independently. FutureHouse integrates human oversight into its AI processes, whereas the AI scientist is designed to operate with minimal human intervention, raising important questions about the future role of scientists in research. 4. Timeline of key events. 2019, Sam Rodriguez proposes new collaborative structures in scientific research in his PhD thesis at MIT. 2022, the release of ChatGPT 3.5 inspires Rodriguez to explore AI applications in science. 2024, FutureHouse releases its AI agents, including Crow and Owl, to assist researchers in literature searches and data analysis. May 2025, FutureHouse officially launches its platform, receiving industry acclaim for its utility in accelerating research. August 2024, Sakana AI unveils the AI scientist, capable of conducting autonomous research, including generating and peer-reviewing its own papers. The future of scientific discovery. As these technologies continue to evolve, they promise to reshape the future of research, creating a landscape where AI plays an integral role in scientific advancement. This transformation could lead to groundbreaking discoveries and a new paradigm in the scientific process. FutureHouse, the path to accelerated research. FutureHouse was conceived from the recognition that scientific progress has been stalling despite the vast reservoir of knowledge available. Rodriguez, during his PhD, noted that the sheer volume of literature makes it nearly impossible for researchers to stay current and synthesize new theories. His collaboration with Andrew White, who had been working with language models, led to the development of AI agents that could effectively perform complex research tasks. The company's platform, launched on May 1, 2025, has since garnered widespread attention. The AI agents are designed to perform tasks like literature searches, data analysis, and hypothesis generation. For example, the Crow agent excels in retrieving and summarizing information from scientific literature, while OWL assists researchers in determining if specific experiments have been conducted. Rodriguez emphasizes that these agents should be viewed as smart assistant scientists rather than mere search engines. The technology has already demonstrated its utility in identifying novel therapeutic candidates, illustrating the potential for AI to significantly enhance research productivity. Sakana AI, a leap toward autonomy. Sakana AI's introduction of the AI scientist marks a groundbreaking step toward fully autonomous scientific research. This system is designed to automate the entire research lifecycle, from idea generation to experiment execution and manuscript preparation. The AI scientist operates iteratively, developing ideas and refining its outputs based on automated peer reviews, mimicking the behaviors of human researchers. In its initial demonstrations, the AI scientist has produced several papers showcasing its ability to discover new contributions in various fields, including diffusion modeling and language modeling. While the current iteration has certain limitations, such as issues with visual data interpretation and the potential for flawed reasoning, it represents a significant stride toward the goal of automating scientific discovery. Ethical considerations and future implications. As with any technological advancement, the rise of autonomous AI scientists raises important ethical considerations. The potential for misuse of these tools could strain the academic process, leading to an influx of automatically generated papers that challenge traditional quality control mechanisms. Moreover, the automated peer review process poses risks of bias and diminished review quality. The implications extend beyond academia. There are concerns that AI-driven research could inadvertently lead to unsafe scientific practices or the development of harmful technologies. As such, the scientific community must prioritize safety and ethical guidelines as these technologies continue to develop. Conclusion. The rise of autonomous AI scientists heralds a new era in scientific discovery characterized by unprecedented efficiency and innovation. Organizations like FutureHouse and Sakana AI are at the forefront of this transformation, leveraging advanced AI technologies to streamline research processes and democratize access to scientific tools. The potential for a 1,000-fold acceleration in discovery rates presents exciting opportunities, but also necessitates careful consideration of ethical implications and the evolving role of human scientists. As these technologies mature, they promise to not only enhance the capabilities of individual researchers but also fundamentally reshape the scientific landscape, paving the way for groundbreaking discoveries that could address some of humanity's most pressing challenges. The rise of autonomous AI scientists, as discussed in the context of FutureHouse and Sakana AI, presents several counterintuitive aspects regarding the future of scientific research and the role of human scientists. 1. AI as a collaborator versus competitor. A common narrative is that AI will replace human researchers, leading to job loss and a reduced role for scientists. However, the developments from FutureHouse and Sakana AI suggest a more collaborative future where AI acts as an assistant or partner. For instance, FutureHouse AI agents are designed to augment human capabilities by taking on tedious tasks like literature reviews and data synthesis, allowing scientists to focus on creative and complex problem solving. This counters the fear of obsolescence and instead points to a transformation of the scientist's role where they can leverage AI to enhance their productivity and creativity. 2. Democratization of research. While one might assume that advanced AI tools would be available only to elite institutions or researchers with significant resources, the initiatives by FutureHouse and Sakana AI aim to democratize access to these technologies. FutureHouse platform is accessible to researchers across various disciplines, enabling a broader range of scientists to benefit from AI tools. This contradicts the expectation that such advancements would widen the gap between well-funded and under-resourced research initiatives. Instead, it may lead to a more equitable research landscape where more voices and ideas can contribute to scientific discovery. 3. Quality control and ethical considerations. One might expect that the automation of scientific research would lead to a decline in quality and rigor due to the potential for errors and biases in AI-generated work. However, Sakana AI has introduced an automated peer review process capable of evaluating generated papers with near-human accuracy. This suggests that AI can not only produce research but also maintain quality control, potentially improving the overall standard of scientific literature. This challenges the assumption that human oversight is the only means to ensure research integrity. For exploration of novel ideas, there is a belief that genuine scientific breakthroughs stem from human intuition, creativity, and serendipity. However, the AI scientist's ability to generate novel research ideas and iterate upon them through a continuous feedback loop indicates that AI can contribute to the ideation process in ways that are not entirely predictable or limited by human experience. This challenges the notion that machines can only replicate existing knowledge or processes, highlighting their potential to explore uncharted territories of scientific inquiry. 5. Economic implications. It is often assumed that the integration of AI into research will lead to increased costs due to the need for advanced technology and training. Yet the report suggests that the AI scientist can produce research papers at a cost of approximately $15 per paper, which is significantly lower than traditional research costs. This raises questions about the economic model of scientific research and suggests that AI could lead to a reduction in the financial barriers associated with research, making it more accessible. 6. Redefining scientific creativity. The concept that creativity is a uniquely human trait is challenged by the capabilities of AI to generate innovative solutions and concepts. As AI systems like the AI scientist demonstrate the ability to propose original research directions, it blurs the line between human and machine creativity. This prompts a re-evaluation of what it means to be a scientist and the nature of innovation itself, suggesting that creativity may not be solely a human domain. 7. The future role of human scientists. While there is apprehension about AI replacing human scientists, the findings suggest a shift in the role of scientists rather than a reduction. The expectation is that scientists will evolve to take on more strategic, supervisory, and creative tasks, partnering with AI to tackle complex challenges. This counterintuitive perspective indicates a future where human expertise is complemented by AI rather than rendered obsolete. In conclusion, the rise of autonomous AI scientists presents a complex and nuanced landscape for the future of scientific research. Challenges to conventional wisdom regarding the roles of AI, the democratization of science, quality control, creativity, and economic implications highlight a transformative potential that goes beyond the simplistic narrative of replacement. Instead, it suggests a collaborative paradigm where human and machine intelligence work in concert to advance scientific discovery. The report on the rise of autonomous AI scientists presents transformative changes in scientific research through platforms developed by organizations like FutureHouse and Sakana AI. While the primary advancements in AI's role in research are highlighted, there are several significant nuances and implications that many may overlook. 1. The nature of collaboration. Most discussions around AI scientists tend to focus on the technological capabilities of these systems. However, the report emphasizes the contrasting approaches of FutureHouse and Sakana AI in terms of human-AI collaboration. FutureHouse adopts a model where AI agents assist human researchers, while Sakana AI envisions a fully autonomous system that operates independently. This divergence raises critical questions about the future role of human scientists. Significance. The transition from collaborative tools to fully autonomous entities implies a potential re-evaluation of the scientific method itself. Understanding the dynamics of this collaboration, or lack thereof, will shape how research is conducted, necessitating new frameworks for accountability ethics. and the definition of scientific authorship. 2. Democratization of research tools. Both FutureHouse and Sakana AI strive to democratize access to advanced scientific tools. This is particularly significant because it could level the playing field for researchers across various disciplines, especially those in underfunded or less developed regions. Significance: democratization might lead to an explosion of innovation from diverse backgrounds, potentially accelerating discoveries across fields. However, it also raises questions about the quality of research produced and the integrity of scientific discourse, particularly if less experienced researchers rely heavily on AI without critical oversight. 3. Economic implications of AI in research. The report mentions that the AI scientist can produce papers at a cost of approximately $15 per paper, which is significantly lower than traditional research costs. This economic efficiency is an important aspect that could disrupt funding models for scientific research. Significance: if research can be conducted more cheaply and swiftly, funding bodies may reconsider how they allocate resources. This could lead to a paradigm shift in research priorities, potentially favoring projects that are scalable through AI while undermining traditional thorough research processes that take longer and require more funding. 4. Ethical and safety considerations. The report highlights the ethical implications of deploying AI in scientific research, particularly concerning the potential for misuse. The ability of the AI scientist to generate and submit papers automatically poses risks to the integrity of the peer review process and could lead to an influx of low-quality submissions. Significance: the challenge lies not only in improving AI systems but also in establishing ethical guidelines and regulatory frameworks to manage their deployment. The potential for generating unsafe research or unethical practices necessitates a proactive approach to governance in AI-assisted research. 5. Implications for scientific creativity. While AI's ability to automate routine research processes is extensively discussed, less attention is given to its implications for creativity and innovation in science. The report suggests that AI may not yet be capable of proposing genuinely paradigm-shifting ideas, which raises existential questions about the nature of scientific discovery. Significance: if AI struggles to replicate the serendipity and creativity inherent in human research, it underscores the irreplaceable value of human intuition and insight in scientific exploration. This distinction is crucial when considering the future of scientific inquiry and understanding the limits of AI. 6. The role of knowledge integration. The integration of various AI tools for literature review, experiment design, and data analysis points to a larger trend of knowledge synthesis in research. FutureHouse approach emphasizes how AI can streamline these processes, but it also hints at the broader implications of how knowledge is constructed and validated. Significance: as AI systems manage more of the knowledge base, researchers must be vigilant about the biases inherent in these systems, which could shape the direction of scientific inquiry. Understanding how these tools interpret and prioritize knowledge is critical to ensuring a balanced and comprehensive approach to research. 7. Potential for long-term evolution of AI in research. The timeline of developments from 2019 to 2025 indicates a rapid evolution in AI capabilities. The trajectory suggests that future iterations of AI scientists will likely incorporate more sophisticated capabilities and could operate even more independently. Significance: this evolution necessitates ongoing dialogue about the balance between human oversight and AI autonomy. As these systems become more complex, the potential risks and benefits will need to be assessed continuously to align developments with societal values and scientific integrity. 8. Cultural shifts in scientific publishing. The introduction of AI-generated papers could initiate a cultural shift in how scientific findings are disseminated and validated. The automated peer review process proposed by Sakana AI could change the landscape of academic publishing, potentially leading to faster dissemination of scientific knowledge. Significance: while this could enhance the speed of scientific communication, It also raises concerns about the quality and rigor of the peer review process. The academic community must grapple with these changes to maintain standards while embracing innovation. 9. Impact on interdisciplinary research. The rise of AI scientists may facilitate interdisciplinary research by providing tools that can synthesize knowledge across various fields. FutureHouse's approach to broadening access to AI tools may encourage collaborations that span traditional boundaries. Significance: enhanced interdisciplinary collaboration could lead to breakthroughs in complex global challenges such as climate change and public health. However, it requires a cultural shift within academia to value and support interdisciplinary work. Conclusion: the rise of autonomous AI scientists represents a profound shift in the scientific landscape with implications that extend beyond technological advancements. As we embark on this transformation, it is critical to engage with the nuanced aspects of these changes. Ensuring that the integration of AI into research enhances rather than diminishes the integrity, creativity, and collaborative spirit of scientific inquiry. The significance of these overlooked elements will shape the future of research and its impact on society at large. The rise of autonomous AI scientists as presented in the content stands to revolutionize the landscape of scientific discovery, promising unprecedented acceleration in research productivity. Here are 4 valuable points for in-depth analysis and discussion. 1. Integration of information and automation in research. The integration of tools for information retrieval, synthesis, experimental design, and data analysis is a pivotal advancement in scientific research. FutureHouse AI agents such as Crow and Owl epitomize this trend by automating critical tasks that researchers traditionally perform manually. This capability not only streamlines the workflow but also enhances the ability to sift through vast amounts of scientific literature efficiently. Discussion points: how do automated tools impact the quality of research outputs compared to traditional methods? What are the potential risks of over-reliance on AI for critical information synthesis and hypothesis generation? Can we quantify the efficiency gains provided by these AI systems in terms of time and resource savings for researchers? 2. The evolution of AI's role in research, collaborative versus autonomous. The divergence in visions between FutureHouse and Sakana AI regarding the role of AI in research is noteworthy. FutureHouse envisions AI as collaborative partners augmenting human researchers, while Sakana AI aims to create fully autonomous systems capable of conducting independent research. This raises critical questions about the future roles of scientists and the ethical implications of such autonomy. Discussion points: what model of AI integration is more beneficial for the scientific community, collaborative or autonomous? How might the shift towards fully autonomous AI scientists affect the training and education of future scientists? What ethical considerations must be addressed as AI takes on more significant roles in research, particularly concerning accountability and oversight? 3. Democratization of research tools. The promise of democratizing access to advanced scientific tools is another significant theme. Both FutureHouse and Sakana AI propose that their platforms provide broader access to sophisticated research capabilities which could empower a wider range of researchers and potentially lead to more diverse scientific inquiries. Discussion points: in what ways might democratizing research tools change the landscape of scientific inquiry, especially for underrepresented groups in STEM? How do we ensure equitable access to these technologies across different regions and socioeconomic backgrounds? What implications does democratization have for the traditional funding and publication models in science? For ethical and safety considerations in autonomous research. The potential for AI systems like the AI scientist to conduct research autonomously brings forth significant ethical and safety concerns. Issues such as the automated generation of scientific papers, potential biases in peer review processes, and the risks of AI conducting unsafe or unethical research warrant careful consideration. Discussion points. What frameworks can be established to ensure ethical standards are maintained in autonomous AI-driven research? How can we prevent misuse of AI technologies in research, particularly concerning sensitive areas such as biological research? What strategies can be implemented to monitor and evaluate the outputs of AI systems to mitigate risks associated with flawed or harmful research? These 4 points encapsulate the transformative potential of autonomous AI in scientific research while also highlighting the complexities and challenges that accompany this technological evolution. Engaging in these discussions can lead to a better understanding of how to harness AI responsibly in the scientific realm. Here are 3 famous historical cases that resonate with the theme of revolutionizing research akin to the rise of autonomous AI scientists and their potential impact on scientific discovery. 1. The Manhattan Project 1942 to 1946. The Manhattan Project was a pivotal moment in scientific history representing an extraordinary collaboration of scientists, engineers, and military personnel during World War II. Tasked with developing the first nuclear weapons. The project brought together some of the brightest minds of the time, including Robert Oppenheimer, Enrico Fermi, and Richard Feynman. Key elements. Collaboration across disciplines. The Manhattan Project exemplified how interdisciplinary collaboration can accelerate scientific discovery. It required expertise in physics, engineering, chemistry, and materials science, leading to breakthroughs that revolutionized the understanding of nuclear fission. Rapid development and innovation. The urgency of war created an environment where traditional research timelines were drastically shortened. The project's success was marked by the development of the atomic bomb in a matter of years, showcasing how focused teamwork and resource allocation can lead to extraordinary advancements. Ethical implications. The project also raised significant ethical questions regarding the use of scientific discoveries. The deployment of atomic bombs on Hiroshima and Nagasaki led to debates about the moral responsibilities of scientists. Similar to contemporary discussions on the ethical implications of autonomous AI in research. 2. The Human Genome Project 1990 to 2003. Launched in 1990, the Human Genome Project (HGP) was an international research initiative aimed at mapping and understanding all the genes of the human species. It was one of the largest collaborative biological projects ever undertaken and involved scientists from various fields including genetics, bioinformatics, and computational biology. Key elements. Massive collaboration. The HGP required unprecedented collaboration between scientists and institutions across the globe, including the National Institutes of Health (NIH) and the Wellcome Trust Sanger Institute. This cooperation exemplified the benefits of pooling resources and knowledge to tackle complex scientific challenges. Technological advancements. The project spurred the development of new technologies in DNA sequencing, data analysis, and bioinformatics, significantly accelerating the pace of genetic research and the understanding of human biology. Similar to autonomous AI in research, the project integrated new technologies that transformed scientific methodologies. Impact on medicine and ethics. The completion of the HGP has had profound implications for medicine ethics and our understanding of genetics. It opened new avenues for personalized medicine and gene therapy while also raising ethical concerns regarding genetic privacy and manipulation issues that parallel current discussions about AI's role in research. 3. The Apollo Program 1961 to 1972. The Apollo program was a monumental effort by NASA to land humans on the Moon and return them safely to Earth. It was a testament to human ingenuity and the ability to mobilize scientific and technological resources toward a common goal. Key elements. Interdisciplinary innovation. The Apollo program brought together experts in various fields including engineering, physics, and biology. The collaborative efforts resulted in technological innovations such as miniaturized electronics, new materials, and improved life support systems, reflecting the potential of integrated approaches to drive scientific progress. Accelerated timeline. The program aimed to achieve its goals within a short timeframe, resulting in rapid advancements that would have taken much longer under normal circumstances. This mirrors the expected acceleration in research facilitated by AI, where tasks can be completed much more quickly than traditional methods allow. Inspiration and scientific legacy. The Apollo missions inspired a generation of scientists and engineers, just as the advent of autonomous AI scientists may inspire future researchers. The legacy of the Apollo program continues to influence space exploration and technology development, showcasing how ambitious scientific endeavors can catalyze long-lasting change. These historical cases illustrate how collaboration, urgency, and technological innovation can lead to groundbreaking discoveries. Paralleling the potential impact of autonomous AI scientists in revolutionizing research and accelerating scientific discovery. The future of scientific research is on the brink of a monumental transformation driven by the emergence of autonomous AI scientists. As we advance into the next decade, we can anticipate a landscape where AI not only assists but also autonomously conducts research, potentially accelerating scientific discovery by orders of magnitude. 1. Acceleration of research productivity. The advent of AI platforms like FutureHouse and Sakana AI signifies a growing trend towards automation in research. FutureHouse multi-agent systems such as Crow and Owl streamline the literature review process and facilitate hypothesis generation, while Sakana AI's fully autonomous AI scientist can conduct experiments, write papers, and even peer review its findings. This synergy of capabilities suggests that researchers will spend significantly less time on routine tasks, enabling them to focus on complex problem-solving and innovative thinking. Predictions indicate that research productivity may increase by up to 1,000 times as these AI systems become more integrated into laboratory workflows and begin to handle an increasing number of scientific tasks independently. 2. Democratization of science. One of the most exciting prospects for the future is the democratization of scientific research. By providing smaller research teams and individual scientists with access to advanced AI tools, we can expect a more equitable distribution of scientific inquiry capabilities. This shift will likely lead to a surge in diverse research projects, particularly in underfunded fields or areas traditionally overlooked due to resource constraints. The platforms will empower a broader range of researchers to engage in scientific exploration, potentially leading to breakthroughs in critical areas such as health disparities and environmental sustainability. 3. AI as a collaborative partner. While the rise of autonomous AI scientists raises questions about the future role of human researchers, it is essential to view these AI systems as collaborative partners rather than replacements. The role of scientists will evolve to focus more on conceptualizing research questions, interpreting complex data, and integrating findings into broader scientific contexts. Human intuition and creativity will remain crucial, particularly in formulating novel hypotheses and ethical considerations in research. The collaboration between AI and human scientists may lead to a new hybrid model of research, combining the strengths of both. 4. Ethical considerations and regulatory frameworks. As AI systems gain the ability to conduct independent research, ethical concerns will come to the forefront. Issues surrounding accountability, bias in AI algorithms, and the implications of AI-driven discoveries will necessitate robust regulatory frameworks. We can anticipate the development of ethical guidelines and oversight committees to ensure responsible AI use in research. Furthermore, there will be a growing emphasis on transparency regarding AI-generated content, including the need for clear labeling of AI contributions in published research. 5. Innovations in education and training. The integration of autonomous AI scientists will also impact education and training in the scientific community. Future curricula will likely focus on interdisciplinary skills, emphasizing how to effectively work alongside AI tools. Training programs will need to adapt, preparing the next generation of scientists to leverage AI for data analysis, hypothesis generation, and experimental design. This evolution in education will foster a workforce that is well equipped to navigate the complexities of AI-driven research environments. 6. Ethics of AI-generated research. The potential for AI to autonomously generate research papers and conduct experiments raises questions about intellectual property and academic integrity. As AI-generated research becomes more prevalent, there will be a need for clear protocols regarding authorship and accountability. The academic community will need to grapple with the implications of AI contributions and ensure that ethical guidelines are established to maintain the integrity of the scientific process. 7. Future research horizons. Looking ahead, the capabilities of autonomous AI scientists will continue to expand. Future iterations may include multimodal AI systems that integrate visual data processing alongside text-based analysis, further enhancing research capabilities. We may see AI systems capable of proposing entirely new research directions and ideas that challenge existing paradigms, potentially leading to revolutionary breakthroughs in fields like medicine, climate science, and materials engineering. 8. Global collaborative networks. As AI democratizes access to research tools, we may witness the formation of global networks of researchers collaborating across borders. These networks will facilitate knowledge sharing and resource pooling, allowing researchers from diverse backgrounds to contribute to addressing global challenges. The rapid dissemination of scientific knowledge will be accelerated, fostering a more interconnected scientific community that can respond swiftly to pressing issues. Conclusion. The rise of autonomous AI scientists heralds a new era in scientific research characterized by unprecedented productivity and innovation. As these technologies continue to evolve, they promise to reshape the landscape of research, making it more accessible and collaborative. While the future holds immense potential, it will also require careful consideration of ethical implications, the evolving role of scientists, and the need for regulatory frameworks to ensure responsible AI use. The next decade will be pivotal in determining how we navigate these changes and harness the full potential of AI in advancing our understanding of the world.